Hi guys, it's me again. Laid back Friday. I got my jeans, I got my IB shirt on, and we're ready to talk about trig identities. And you might be like him, saying, what is a trig identity? Well, a trig identity is nothing more than an equation that has sine, cosine, and tangent in it. And you use it to solve equations to find x just like you would any other equation. And as a matter of fact, you know some already. I bet you didn't even know you did. The first one we learned last semester was sine squared x plus cosine squared x is equal to 1. Whenever you have this in an equation, you can substitute sine squared x plus cosine squared x for 1. And we also know that tangent of x is equal to the sine of x over cosine of x. So if we have sine of x over cosine of x in an equation, we can replace it with tangent of x, and vice versa. Well, today we're going to learn about a special type. There's several types, but the first one is what we call the double angle identities. Now, the double angle identities are the double angles for sine and the double angles for cosine. We're not going to learn double angle for tangent, and we'll explain why later. Now, for cosine, we have 3 different possibilities. That doesn't mean you use all 3. You can use any of the 3, but you use only one per equation when you're solving it. And it all depends on what it is that you have, and that's a tricky part, trying to figure out which one of these equations to use when you're solving a trig equation. I'm going to be having several trig equations here, and I might be using some and not using others. And that's a tricky part with cosine of 2 theta, because with cosine of 2 theta, you have 3 to pick from. With sine, it's easy. The double angle for sine is just 2 sine theta cosine theta. So when you see sine of 2 theta, which we saw in a practice problem, if you remember, in 13C or 13D, where we had sine of 2 theta, and we used a little common sense, but now we're not. We're going to use the formula. Okay? Now, a lot of people get confused with the double angle formulas because let's say theta is 30, and we know the sine of 30 is 1/2. Well, if I double that, and now I have 30 and 30, and I have 60, do I just double the sine? Well, what is double 1/2? It's 1. Is the sine of 61? No, it's not, is it? Okay, so we have to learn what to do in those situations. So we're going to use both of these identities to solve equations and find theta. Now, some of them are easier, some of them are a little harder, but let's take this problem for instance. It says the sine of x is equal to 3/4, and x is somewhere between 0 and 90 degrees. And they want you to find the exact value for the cosine of x, the sine of 2x, the cosine of 2x, and the tangent of 2x. Well, let's get started. First of all, if they're giving me sine of x is equal to 3/4, whenever you're given this, you have to go back to your days of geometry and earlier this semester when we talked about SOHCAHTOA. And I'll write it up here. SOHCAHTOA. And we know that the sine of an angle, let's say, well, a right triangle, if this angle is x, then the sine is the opposite side to this angle over the hypotenuse. So opposite this side is this angle, which would be 3. And the hypotenuse would be 4. Now, using this, it's easier than to use identity like sine squared theta plus cosine squared theta is equal to 1. I can use that, and the book uses that, but I prefer to draw the triangle once I have sine to find cosine. All I need to find is cosine and find what this is. To find what this is, all I really need is Pythagorean theorem. and I say 4 squared minus 3 squared is equal to, well, I don't know, I guess we'll call this y, or c, better yet, I prefer c squared. So I get 16 minus 9 is equal to c squared. 7 is equal to c squared. So c, or this side, is equal to the square root of 7. Make sense? Hopefully it does. This side is 3, this side is 4, and this side is square root of 7. So for question 1, they're asking me what's the cosine of x? Well, here's x. Cosine is adjacent over hypotenuse, so that would be square root of 7 over the hypotenuse, which is 4. So the cosine here would be square root of 7 over 4. Hopefully that makes sense. Now, let me erase this so we can find sine of 2x. What is this double angle for x? Well, if I wanted to find the sine of 2x, there's other ways to do it, but the easiest way is to use the double angle formula. And as you know, sine of 2x is equal to 2 sine x cosine x. Well, the problem gave us what the sine of x was, and we just figured out what the cosine of x was, so we're going to put it here in the formula. Sine of 2x is equal to 2. The sine of x is 3 over 4. And the cosine of x, which we just figured out, square root of 7 over 4. When you multiply this out, the sine of x, well, 2 goes into 4, and you're going to get 3 square root of 7 over 8. And that is the sine of 2x, which, as you see, just because I double an angle doesn't mean that I double its sine. The sine for x was 3 over 4. If I doubled it, I would have gotten 6 over 4. But no, my answer is 3 square root of 7 over 8. Now, to use, or to figure out part C, this is part B. Well, technical difficulties again. This is part B. This was part A, the triangle. Now to figure out part C, I'm going to use the double angle formula for cosine of 2x. Now we have 3 to choose from. I'm choosing to use cosine of 2x is equal to 1 minus 2 sine squared x. So to figure that out, I need to know what sine of x is, which I already know is 3 over 4. I could have used probably any one of them because I know sine and I know cosine, so I could have used any one of the 3. I chose to use this one. I get 1 minus 2. The sine of x is 3 over 4. And I'm going to square that. So I get 1 minus 2 times 9 over 16. If I simplify, oops, let me extend a little bit. If I simplify, I get 1 minus, well, 2 and 8. I get 9 over 8, which is going to give me negative 1/8. 1 is 8 over 8, minus 9 over 8 is negative 1 over 8. I hope that made sense. And then finally, D, the tangent of 2x. Let's do d over here. The tangent of 2x. Well, this is from the one that we learned before, the sine over cosine. So the tangent of 2x is equal to the sine of 2x over the cosine of 2x. The sine of 2x is 3 square root of 7. And the cosine of 2x is negative 1/8. And if we simplify it, that's like saying 3 square root of 7 over 8 times negative 8 over 1. So basically this is going to cancel out. I'm going to get negative 3 square root of 7. And that's my answer for part D, the tangent of 2x. Take a Coke break for a second. I'm getting no sponsorship. Don't want any. Okay? So we understand that, hopefully. If there's any part that you didn't understand, make sure you write this down in your notes, because I'm going to check your notes that you took notes down for homework. The next example, they're giving me that the cosine of theta is 4 over 5, and they want to know to find the exact value of sine of theta and cosine of 2 theta from 3 pi over 2 to 2 pi. So that's a really small distance. 3 pi over 2 is 270 degrees. So from 270 degrees to 360 degrees. All right? So using the same triangle, assuming this is theta, cosine is adjacent over hypotenuse. This is 4, and the hypotenuse would be 5. Opposite hypotenuse. So to figure out this, I use Pythagorean theorem. 5 squared, I'll do it up here. 5 squared minus 4 squared equals c squared, or a squared. And I get 25 minus 16. So a squared is 9, so a is 3. Knowing that a is 3, well, now I can easily figure out what the sine is. Remember, when they give you the cosine and they're asking you for the sine, the easiest way is not to use identity, it's to use SOHCAHTOA and to use the Pythagorean theorem. So now my sine of theta is going to be the opposite over the hypotenuse, which is going to be 3 over 5. Now for part B, I need to find the double angle formula for 2 theta. So I'm going to use one of the 3, and I think I'll use the second one, which is going to be equal to 2 cosine squared theta minus 1. 2 is still 2. Cosine is 4 over 5 squared minus 1. I square it first, order of operations, and I get 2 times 16 over 25 minus 1, which is going to give me 32 over 25 minus, and I'll write 1 as 25 over 25. And 32 minus 25 is going to give me 7 over 25. And that is the double cosine of 2 theta. And again, you'll see that if I double the angle, I don't necessarily double the sine. If I double theta, I'm not going to double 4/5. 4/5 would be 8/5. And that's not my answer. It's 7 over 25. So that's where a lot of people get confused. Why, if I double the angle, don't I just double the sine? And unfortunately, it doesn't work that way. All right, let's take a third example. Solve the equation sine of 2x is equal to sine of x for 0 to 360. And they're telling me I cannot use my GDC. Well, the sine of 2x only has one identity. So here, sine of 2x, I'm going to rewrite it as 2 sine theta cosine theta is equal to the sine of x. Oh, they're using x instead of theta. I'm just so used to using theta. Sometimes it's hard for me to use x. Okay, now from here, there are several different ways that you can approach this, and you want to be able to figure out an answer, a number, to figure out what number this is going to be. In other words, which angle is going to be the same whether I double the angle as I don't double the angle. So this is what we have to do. All right, so I'm going to bring the sine over to the other side. I'm going to get 2 sine of x cosine of x minus the sine of x equals to 0. I'm going to factor out a sine of x. Is giving me 2 cosine x minus 1 is equal to 0. All right, so now I have to figure out where, for these two factors, where am I going to get an answer of 0? So first I say, okay, what angle, and it's in degrees, so we're going to answer in degrees, what angle gives me a sine of 0? Well, that's obviously 0. And what angle is going to give me 2 cosine of x minus 1 is equal to 0? So I solve this, and I get 2 cosine x is equal to 1, and I divide both sides by 2, and I get cosine of x is equal to 1/2. Now, what angle gives me a cosine of 1/2? That would be 60 degrees. Now let's see. Let's see if this works. If I were to take 60 degrees and plug it into here, what's the sine of 2 times 60? That's 120. And if I plug in sine here, the sine of 60, well, if you remember from our unit circle, this would be 60, and this here would be 120. In other words, the supplementary angle would be 60 here, so they both have the same y value. So both of these answers are correct. Sine of 0 and sine of, for 0 degrees and for 60 degrees. Both of them will give you the same sign. The third problem, this is going to be a little bit more complicated. Now, this is a proof. In IB, when you are asked to prove that this equals this, the key here is I cannot touch this part. I'm going to manipulate this part to look exactly like this part. In other words, I can't bring stuff back and forth. At least I don't want to. I want to take this part, manipulate it until it looks identical to this part. Okay? So the first thing I want to do is I want to figure out here the cosine 2x. And here I'm going to use, and sometimes this is a trial and error process. Sometimes you use one for cosine and realize maybe it would have been better. Not that it can't be solved. It can be solved with any one of them. It's just harder to make this look like this. So sometimes you're going to require a little bit of trial and error. So I'm going to write 1 plus tangent squared x, and instead of cosine of 2x, I'm going to use 2 cosine squared x minus 1. And this should equal to 1 minus tangent squared x. All right? Now here I have a binomial 1 plus tangent squared. Here I have a binomial 2 cosine squared x minus 1. When I have two binomials, my impulse is to FOIL. And that's exactly what I'm going to do. I'm going to multiply 1 times 2 cosine of x, and I'm going to get 2 cosine squared x. 1 times negative 1 is negative 1. Multiply here, and I get tangent squared x times 2 cosine squared x. I'm going to get plus 2 tangent squared x cosine squared x. And if I multiply this times here, I get the minus tangent squared x. Notice here, I already have this part, the minus tangent squared x. So I've got to make this whole thing equal to 1. Not an easy thing to do, but little by little, 1 minus tangent squared x. So how do I make this whole thing equal to 1? Well, first, let me get this part and this part close together. So I'm going to rewrite it as 2 cosine squared x plus 2 tangent squared x cosine squared x minus 1. Obviously, I'm bringing this down. Tangent squared x is equal to 1 minus tangent squared x. So I have this complicated looking piece here, and I need to make this whole thing equal to 1. So here, in here, and here, I have a 2 cosine squared x. So let me try writing 2 cosine squared x equals 1 plus tangent squared x. Minus 1. Now, better yet, tangent we know is sine over cosine. So I'm going to rewrite this as sine over cosine. So this is 2, whoops, put it in the wrong place. 2 cosine squared x plus 2 sine squared x cosine squared x times the cosine squared x minus cosine squared x minus 1 minus tangent squared x equals 1 minus tangent squared x. I'm sure your minds are going 1,000 different ways. We'll go over it again. All right, what I did from here to here, well, from here to here, I FOILed it. What I did from here to here, all I did was I switched that minus 1 over here and the tangent over here. Then from this step to this step, I used my identity that tangent is equal to sine over cosine, and I changed this instead of tangent squared x to sine squared x over cosine squared x. I kept the cosine squared x and the minus 1 the same. Now, here, if I'm multiplying sine squared x over cosine squared x times cosine squared x, the cosines will cancel. And this will leave me with 2 cosine squared x plus 2 sine squared x minus 1 minus tangent squared x equals 1 minus tangent squared x. Now guys, don't think this is easy. It's not. But it does require persistence. You're going to have questions like this. You're going to have to try and keep on trying. And if it doesn't work, you need to try another identity. And if it doesn't work, you got to keep on trying. You just can't give up. Well, here I have a 2 in common. So I factor out a 2 and I get cosine squared x plus sine squared x minus 1 minus tangent squared x, and that's equal to the 1 minus tangent squared x that we know we're not allowed to touch. So the right side of the equation has remained the same throughout. Well, another one of our identities is cosine squared x plus sine squared x is equal to 1. So this whole thing right here is equal to 1. So if I multiply 2 times 1, I get 2 minus 1 minus tangent squared x equals 1 minus tangent squared x. We're getting closer. 2 times 1 is 2, minus 1 is 1 minus tangent squared x, and this is 1 minus tangent squared x. So what did we do? We made the left side look like the right side. It took us some steps, and we made an error in the middle. And that's normal. It happens to everybody. You can't just take a look at one of these and know what the answer is. Unfortunately, trigonometry is one subject that you're really going to have to trial and error with. So unfortunately, there's no way around that. You're unfortunately going to have to be able to work with this and keep on trying. And persistence is key, guys. Please be persistent when you're doing this. Don't just stop and say, I give up, I don't know. It's too easy to say that, and with trig, it's that way. But remember, trig is only one section of all the sections that we've been covering in class this year. And that's it. That is the last example that we have for today. Go through the notes. Make sure that you write down the notes, because next time in class, the first thing I'll do is check that you did the questions. I'm sorry. I'm going to check that you did your notes. That's what I'm going to grade you on for watching the video. So bring the notes with the examples so that I know that you watched the video. If you don't bring the examples in, then I'm going to give you a 0 for the homework. So make sure you bring on the notes with the examples, and we'll work together. Now remember, the key is to be able to try some from every section so that when we go home and we want to re-practice these, we understand them. Now, again, this is not an easy topic. Trigonometry wasn't meant to be easy. It was just meant to be. So please go over this. We'll work on it in class, and we'll get through this together. If you have any questions, feel free to email me and ask me about anything on the video. All right? Have a good weekend.